Alright, so welcome back to your favorite inorganic YouTube channel. Today, basically, we are going to look at how to solve some multiple choice questions under differentiation as well as analytical geometry. Alright, so now let's begin. So our first question is, we want to look at how to solve. We want to look at how to find the slope of the normal to the curve, the slope of the normal to the curve y equals log x, y equals log x. All right, we want to look at how to solve the slope of the normal at y equals log x. All right, so first we have to find the slope of the normal. So finding the slope of the normal, we first need the slope of the tangent. All right, the slope of the tangent. So the slope of the tangent to this curve at x equals 1, as x equals 1, we have to first find the derivative of this particular function. All right, so we first find the derivative of this particular function, and we know that this log x is equal to ln x, right? So finding the differential of this particular thing, we have y prime or dy dx is equal to 1 over x. All right, so this is the differential of log x, right? And then they said at x equals 1, at x equals 1. So now at x equals 1, we have 1 over 1, and that is equal to 1. All right, and they said the actual question is find the slope of the normal to the curve y equals log x at x equals 1. All right, so now after finding the differential of log x and then placing the value of x and finding the differential of 1, the value of 8, we now go ahead and find the slope of the normal. Find the slope of the normal, and we know that the slope of the normal is the negative reciprocal of the tangent. All right, is the negative reciprocal of the tangent, and so we know that this is the tangent. All right, so the negative reciprocal of the tangent will be equal to negative 1 over 1. All right, and that's equal to negative 1. All right, so that is the slope of this normal. All right, so this is the slope. Good. So that's the solution to this particular question. So now let's move on to question 2. Question 2. So let me go over the question 1 again. They said find the slope of the normal to the curve y equals log x. All right, at x equals 1. All right, and now finding the slope of a curve, we first find the derivative. All right, so you find the derivative of this particular function. All right, and you know that log x is the same as ln x. All right, and then differentiating ln x, we have 1 over x. Good, and they said x is equal to 1. So now we place 1 in place of what? X, and we have 1 over 1. So now the differential of log x is equal to 1 over x, and then x is 1. So we have y prime equals 1. Now, they said we should find the slope, all right, slope of the normal. So finding the slope, you have to find the tangent, all right. So we get the tangent to be 1, and we know that the negative reciprocal of the tangent will give us the slope of the curve, all right. So this is the answer to this particular question. Next question is you have to find the slope of the curve y equals 9x squared plus 7x 4 plus 7x4. All right. So this particular question too is demanding us to find the slope of the curve. All right. So to find the slope of the curve, we take the derivative of this particular function. All right. The derivative of y with respect to x. All right. So we have dy dx is equal to differential of this particular function. All right. And we have 18x plus 28x cubed. All right. And now they said at x equals 1. All right. So we have dy dx equals 18 into 1 plus 28 into 1 cube. And that's equal to 46. All right. So the slope of this curve at s equals 1 is equal to 46. All right. Note the difference between this particular question and this. All right. The first question said the slope of the normal. All right. The slope of the normal. And we know that the slope of the normal is the negative reciprocal of the tangent. All right. And this particular question is interested in the slope of the curve. All right. So with the slope of the curve, after finding the first derivative and substituting the value of the variable, whatever it gets will be the slope of the curve. All right. So the next question is question 3. They said we should find the equation of the tangent. The equation of the tangent at y at 1 and 2. The equation of the tangent at 1 and 2 on the curve y equals 9x squared plus 7s4. All right. Good. So finding the equation of the tangent at 1 and 2 on the curve, this equation, first, we have to, doing this, we need to find the derivative of this particular function. All right, of this particular function. All right. And we know that the derivative of this particular function will give us 18x plus 28s cubed. All right. And they said at 1 and 2. All right, at 1 and 2. So now we know that dy dx, which is equal to the y prime, the first derivative is equal to 18x, or is equal to the slope. All right, and it's equal to this 18s plus 28s cubed. All right, and they said at 1 and 2. So now at 1 and 2 means x is equal to 1. All right, so now our slope will be equal to 18 into 1 plus 28 into 1 cube, and then we have our slope to be 46. We have our slope to be 46, and then we are asked to find the equation of the tangent. All right, equation of the tangent. So equation of the tangent is given by y minus y1 equals m into x minus x1. All right, and now we are going to use the point that was given, all right, to find the equation of the tangent. All right, so this is our slope or the gradient, right? So now we have y minus 2 is equal to 46 into x minus 1. All right, and this will give us y minus 2 equals 46x minus 46. All right, and this simplified very well will give us y equals 46x minus 44. All right, so this is the solution to this particular question. All right. So y equals 46 x minus 44. Y equals 46 x minus 44. So let's analyze the question 3 again. They said we should find the equation of the tangent at 1 and 2 on this particular point, 1 and 2, on the curve, this particular curve. All right. So now we first find the first derivative of the curve, and that will represent the gradient, all right, or the slope of the curve. Now we know that the first derivative represents the slope of the gradient, right? So now we take the value of x and substitute inside to find the slope, and we had the slope to be 46. Now we use the slope and the 2 points given, all right, the point given to find the equation of the tangent, and that's the solution we have over here. Y equals 46x minus 44. So now let's move on to question number 4. Question number 4. So our question number 4 says we should find the differential of f of x. The differential of f of x equals s squared e power x at x equals 1. At x equals 1. All right. So to find the differential of this particular function, we first find the derivative of this particular function. All right. And then you know that this particular function are two functions multiplying each other. So then we use what we call the product rule. All right. So here, using the product rule, we know that the product rule says that if two functions are multiplying, then we first maintain the second function, differentiate the first function with respect to x, plus we maintain the first function, differentiate the second function with respect to x. So that is the rule for the product, or the product rule. All right. Now we have to find the derivative of this particular function using the product rule. All right. So now dy dx is equal to, right? Dy dx is equal to, we differentiate the first one, and we have 2x e power x, right? When you differentiate x squared, you have 2x, and then you maintain the second function, which is the e power x, all right? Plus we differentiate the e power x, all right? And that remains the same, all right? That remains the same. And then we write the first function, which is the x squared, all right? And then that will be the differential of this particular function. That will be the differential of this particular function. So here dy dx is equal to e power x. E power x is common here, so we have e power x into 2x plus s squared. 2x plus s squared. And that is the first derivative of this particular question. And the question asks for the differential of f of x. So that's basically the differential of this particular function. And it went ahead to give us the value of s, right, at x equals 1. So now dy dx is equal to e power 1, which is the x, into 2 into 1 plus 1 squared, right? And we know that e power 1 is still 1, all right? It's still 1. So 2 plus 1, and then this perfectly yields 3. This perfectly yields 3e. All right, yields 3e. So the question 4, let me go over again. It says you should find the differential of this particular function, and this particular function is following the product rule. All right, so we first differentiate the first function, maintain the second function, and that's what we have here. Maintain the first function and then differentiate the second function, and that's what we have here. All right, note that when you differentiate any exponential function, right, this e power x, it still remains the same. The reason being that you differentiate the exponent, which is the x, and then you use it to multiply the whole function. All right, and you know that when you differentiate x, you get 1. All right, and 1 multiplying this whole function is the same thing. All right, so that's why we keep on getting same thing whenever we differentiate e power x. All right, so good. Now we have the differential of this particular function, and they said at x equals 1. So now replacing the value of 1, and that yields this particular solution 3e. We know that e power 1 is the same as e, so we have the inside to be 3, so we have 3e. All right, so let's move on to question number 5. Let's move on to question number 5. Question number 5. All right, question number 5 says we should find the first derivative of a cos x plus b sin s plus c all over sin s. All right, so this is the function given, and we are to find the first derivative, all right, of this particular function. All right, so this particular function, we can see that it's following the product, the quotient rule. All right, a function dividing another function, we use the quotient rule to differentiate it. All right, so now using the quotient rule states that whenever you want to differentiate a function with respect to x, we first differentiate the first function and maintain the second function, all right, with respect to x, minus differential of the second function with respect to x. Then we divide by the square of the second function, which is the v squared. All right, so we are going to follow this particular rule to differentiate this particular function. All right, so now we have this function is the same as y equals that. So we have dy dx is equal to differential of the first function. All right, differential of the first function will be we have sin s. So let's maintain the second function first, right, and differentiate the first function. So we have let me go by this. So we know that our u of x is equal to the numerator, right? So we have a cos x plus b sin x plus c, right? And the denominator, which is the u of the v of x, will be the sin x, right? So the u of x is the first function and the v of x is the second function. All right, so now let's differentiate the first function. With respect to x. So differentiating this first function is going to be minus a sin x right? When you differentiate cos, you get minus sine, right? Then we attach the a, all right? Plus, you differentiate sine, you get cos, all right? So we have b cos s. And then you know that when you differentiate constant, you get 0, all right? So this is the differential of the first function, which is the numerator, all right? The u of x. Now, let's differentiate the second function, which is the denominator, the sine x, all right? You know that when you differentiate sine x, you have cos x, right? So now, let's apply the quotient rule and then substitute it into the formula, right? So now, we have dy dx equals sine x into negative cos x plus b cos x b sine x, right? Negative sine s plus b cos x, right? And then minus a cos x plus b sine s plus c multiplied by cos x, right? And then all over sine squared s, sine s all squared, right? So let me go over again. We differentiated the u of x, which is the numerator, and we have minus sine s plus b cos x, right? And then we differentiated the sine s, which is the denominator, which is representing the u, the v of x, right? And then we have cos x. And the formula states that you maintain the first function, the second function, differentiate the second function, right? The formula states that you maintain the second function, differentiate the first function with respect to x, minus maintain the first function, differentiate the second function with respect to x, all over the square of the second function, right? And that is what we have here. So just substitute, we are just substituting the differentials into the formula, and then we find the derivative of that particular function. So now, let's simplify this expression. So we have dy dx is equal to minus a sine squared s plus b sine s cos x, right? Minus a cos squared s minus b sine s cos x, right? Minus c cos x, all over sine squared x, sine s all squared is this sine squared s, right? So now we have dy dx is equal to, so combining these items, you can see that this has something to do with this, right? So we have minus a sine s sine squared s minus a cos squared s, right? Then this particular one will take off this particular one, plus b sine s cos s minus b sine s cos s will take off, they will cancel out, right? and then we have this ones remaining here, minus c cos x, right? All over sine squared x, right? So here we have dy dx is equal to this. We can do something about it, right? So we have minus a out, and we have sine squared s plus cos squared s, right? Minus c cos x, right? All over sine squared s, right? And we know that this one is giving us a particular identity, all right? It's giving us a particular identity. We know that sine squared s plus cos squared s is equal to 1, right? So now when we substitute this identity into this expression, we are going to have dy dx is equal to minus a into 1 minus c cos x all over sine squared x, right? So writing this nicely, we are going to have minus a minus c cos x all over sine squared x. So this becomes our solution to the differential of this particular function, all right? So it's just the matter of you understanding the quotient rule, and then you can be able to deal with it very easy, right? So now let's look at some identities that can replace this particular solution. Let's look at some identities that can replace this particular solution. So now we can still go ahead to do something about this solution, right? So we have dy dx is equal to minus a minus c cos x all over sine squared x, right? Now we can divide through by sine squared s, right? And then we have dy dx is equal to minus a over sine squared x minus c cos x over sine squared x, right? Good. So from here we can see that this particular one, dy dx is equal to minus a times 1 over sine squared x, right? Minus c cos x over sine x times 1 over sine x, right? We have been able to split this solution into this part, right? And then we are still splitting it to be able to fit it into a simple solution, all right? So here we can see that 1 over sine squared s is equal to cosec squared s, right? So dy dx is equal to minus a times cosec squared x, right? 1 over sine squared x is the same as cosec squared x, right? Minus, we know that cos x over sine s is what? Cot, right? So minus c cot x times 1 over sine x, we also know as cosec sec squared x, right? 1 over sine x is the same as sec s, right? So cosec s, right? So this is going to be our solution. So in differentiation, you have to remember your trig identities, and it's going to be easy for you. We know that 1 over sine squared s is the same as cosec squared s, right? And then cos over sine is cot, right? And then 1 over sine s is the same as cosec s, right? So we place in those identities, and then our solution simplifies to divide is the s equals minus a cosec squared s minus c cot s cosec s. So this becomes the final solution to the differential of a cos s plus b sine s plus c over sine x. All right, this becomes our final solution. So now let's move on to question number 6. Question number 6. So our question number 6 says that f of x is equal to 4 log s cubed, right? 4 log s cubed, and we have to find the first derivative of this particular function. We have to find the first derivative of this particular function. All right. So given this particular function, and we have to find the first derivative, first we need to simplify the function. All right. We need to simplify the function. So we know that f of x, which is equal to y, is equal to 4. So now we are going to apply logarithm rules. So now we know that this can go here, right? I have 4 times 3, right? Then log x. Very simple. Logarithm rules. When you understand the logarithm rules, you understand how this came about. When you have an exponent like this, it can go down, and this two can equally go up, right? So now let's go ahead. We know that this f of s or y is equal to this multiplying this. You have 12 log s, right? And we know that log s is the same as ln x, right? So we have 12 ln x. All right. So this particular solution, now we've simplified it to the simplest function so that we can differentiate it. All right. So differentiating this particular function, the first derivative of this is equal to 12 times the differential of ln x is 1 over x. All right. So now I'm basically going to have 12 over x as the first derivative of this particular function. All right, as the first derivative of this particular function. So now let's move on to question number 6. Question number 6. 7. So this is basically question number 6. So let's move on to question number 7. So question number 7 says we should find the differential of this particular function. The differential of this particular function, f of x, is equal to s squared tan x. S squared tan x. All right. So from here, given this particular function, and we are asked to find the derivative of it, finding the derivative of it or the differential of it, first we use the product rule. We can see that there are two functions, s squared and tan x. All right. So we are going to use the product rule, which we earlier on stated that dy dx is equal to, we maintain the second function, differentiate the first function with respect to x, then we maintain the first function, differentiate the second function with respect to x. Alright, so that is the product rule. So let's now follow the product rule and differentiate the items one by one. Alright, so where u of u is equal to s squared, right? And then v is equal to tan x, right? So now we have been able to identify the u and the v's, right? So now let's differentiate the u. So differentiating the u with respect to x, we are going to have 2x, right? And then differentiating the v with respect to x, we are going to have, differentiating tan x, we know that is equal to sec squared x. The differential of tan x is equal to sec square x, right? So now let's fit in the differentials. So now we maintain the second function, which is the tan x, and then differential of the first function, which is the 2x, right? Plus maintain the first function, which is the s squared, plus times the differential of the second function, which is sec squared x, right? So let's rewrite this very well. So we have 2x tan x plus s squared sec squared x as our solution to this particular function. So now we can simplify this, and we have dy dx is equal to x out, and then we have 2 tan x plus x sec square x inside, s sec square x inside, right? So this becomes the differential of this particular function. So now let's move on to our question number 8. So our question number 8 says we should find the question number 8 says that the function f of x, question number 8, the function f of x is equal to x plus cos x, right? The function f of x is equal to x plus cos x is what? Is it always increasing, always decreasing, always increasing for a certain range of x, or none of it? Okay, so now let's look at how it will behave. This particular function, how will it behave? Will it always increase or always decrease, or it will increase based on a particular range of x, right? So to determine whether the function is always increasing, first, to determine whether this particular function is always increasing, decreasing, increasing, decreasing, or decreasing in a certain range, we need to first find its derivative. All right, so to either determine whether a function is increasing, decreasing, or decreasing in a particular range of x, first we have to determine the derivative. All right, the first derivative of this particular function. All right, so finding the derivative of this particular function, we are going to have f prime of x, or y prime is equal to 1 1 minus sine s, right? 1 minus sine x. So now the sign of this particular function, will tell us about the behavior of the function. All right, the sign of this particular function will tell us about the behavior of this particular function. So if f of x is greater than 0, then the function is always increasing. All right, if f of x is greater than 0, then the function is always increasing. And b, you have to know the conditions very well. If f of x is greater than 0, then the function is always increasing. All right, and then if f of x is less than 0, then the function is decreasing. All right, now let's analyze this function. All right, and see if it will decrease, increase, or decrease in a particular range of x. All right, so now looking at this function, the range of x, we know that the range of sine s, is -1 and 1 inclusive. All right, the range of sine x is -1 and 1 inclusive. All right, now because we know that the range of x, this particular function sine s, is between -1 and 1 inclusive, then we can say that when sine x is equal to -1, then the first derivative of x will be equal to 1 minus into -1, and that is equal to 2. All right, and then since 1 minus sine x is always greater than or equal to 0 and never gets negative, all right, since 1 minus sine x is always greater than or equal to 0 and never negative, it's never negative, then the particular function or this particular function is always increasing. Let me go over again. To analyze whether this particular function is increasing or decreasing, we have to first find the first derivative. All right, so after getting the first derivative of this particular function, of which it is 1 minus sine x, now we have to analyze the function and see if it is decreasing or increasing or a decrease in a particular range of x. All right, so now we know that the range of sine x is between -1 and 1 inclusive. All right, the range of sine x is between -1 and 1 inclusive. So since -1 and 1 inclusive, then sine s is equal to -1. All right, and if sine s is equal to -1, then we have 1 minus into -1, and that is equal to 2. All right, and then since 1 minus sine x is always greater than or equal to 0, since 1 minus sine s is always greater than or equal to 0 and never negative, we can see that it is never negative, then the first function or the first derivative of this particular function or the derivative of this particular function or the this particular function will always increase, So therefore f of x equals x plus cos x is always increasing, right? It's always increasing because 1 minus sine s is always greater than or equal to 0, because when you put in -1 into this, we have 2, and when we put in 1 as well, we have 0. So it's always greater than or equal to 0. All right, So this particular function is always increasing. So now let's look at number 9. Let's look at number 9. Number 9. So our next question, which is our 9th question, says that we should find a constant c that will make the function f of x equals s squared minus 1 all over x minus 1 if s is not equal to 1 and then if x equals 1. We have to find the constant c of this particular function. The constant c that will make this particular function continuous at s equals 1. At s equals 1. Alright. So at s equals 1, we want to see the value of c, or the constant value c, that will make the function continuous, or the function keep to be continuous. Alright. So now this is our question number 9, right? So now finding the constant c that will make the function continuous at s equals 1. Now, first, you have to ensure that the function is continuous at s equals 1, right? So now the limit of this particular function, as s approaches 1, right? As s approaches 1, must be equal to f of 1. Alright, must be equal to f of 1. So first, let's simplify s squared minus 1 all over x minus 1. Right? Let's simplify s squared minus 1 all over x minus 1 for s not equal to 1 and x. Right? So now, simplifying this particular function, we are going to have x minus 1 and x plus 1, right? All over x minus 1, right? We know that this is difference of 2 squares, so we have 2 brackets in here. And so this takes off this, and we have x plus 1. Alright, so having this, we can now say that the limit as s approaches 1 of this particular function is equal to 1 plus 1, and that's equal to 2, right? So for the function to be continuous at s equals 1, we need the constant, the c, to be equal to 2. So now we can say that the constant c is equal to 2. Alright, so first take the function inside and then simplify it. After simplify it, we are seeing that s plus 1 is left, right? So now for the function to be continuous at s equals 1, then the limit of this particular function must approach 1, and it should be equal to f of 1, right? So having that, we are seeing that this simplifies to this, and then when we plug in x equals 1, we have 2. So the constant here is 2. Alright, so that will be the solution to this particular question. So question number 10. Alright, our question number 10 says that if g of x is equal to x power 1 over 3 into 8 minus x, then we have to find the critical numbers of g of x. The critical numbers of g of x. This is the question given, the function given, and we have to find the critical numbers of this particular function. All right. So now, finding the critical numbers, to find the critical numbers of this particular function, g of x, we need to find the value of x where the derivative g of x is 0 or undefined. All right. We need to find the derivative, the value of x. All right. Where the derivative of g of x is 0 or is undefined. All right. So first, let's find the derivative of g of x. All right. Using the product, we can see that there are two functions multiplying together. All right. So let's use the product rule to find the derivative of g of x. All right. So now we can see that u is equal to x power 1 over 3. Right. So the differential of the u will give us u dx is equal to 1 over 3 x power minus 2 over 3, right? And then the v is equal to 8 minus x, right? So we have the v, the x is equal to minus 1. The differential of 8 minus x is minus 1, all right? So now, with regards to that, with respect to that, we can see that when you follow the product rule, differentiating the first function, which is this, then we maintain the second function, which is this. We have 1 over 3 x power minus 2 over 3, then the v, which is 8 minus x, plus the differential of the second function, which is minus 1, right, into the first function, which is x power 1 over 3, right? So this simplifies to 8 minus x, 8 minus x power 8 minus x, x power minus 2 over 3, all over 3, right? This is basically over 1. So this is also over 1. So we see this will multiply this and this will be over the 3, right? Minus x power 1 over 3. Minus x power 1 over 3. So to simplify this, we combine the terms over a common denominator. All right. To simplify this expression, we combine the terms over a common denominator, right? And here, the common denominator over here is 3. The common denominator over here is 3. The common denominator over here is 3. So now, we can see that the g of x, or the first derivative of g of x, is equal to 8 minus x 1 over 3 times 3x power minus 2 over 3. Alright? All over 3x 2 over 3. Right? So we say that the first derivative of this particular function, g of x, will be equal to 8 minus x minus 3x power 3 over 3, right? And then we have all over 3x 2 over 3, right? So this will basically yield, we can see that it will basically give us 8 minus x minus 3x, right? This will be 1, right? 3 over 3 is 1. All over 3x 2 over 3, right? So this, we can see that minus x and minus 3x will give us 8 minus 4x all over 3x 2 over 3, right? So this, the first derivative of this particular function, all right? The first derivative of this particular function. And we have to find the critical numbers. We have to find the critical numbers. So getting the first derivative, we do, the next thing we do is that the numerator must be equal to 0, all right? The numerator must be equal to 0. So setting the numerator equal 0, we have 8 minus 4x, right, equals 0. And this gives us 4x equals 8, and that's x is equal to 2. All right. And then we also consider where g of x, or the first derivative of x, is undefined. All right. This part, the denominator. So when we consider that as well, we have 3x power 2 over 3, and that is equal to 0. So we also say that s is equal to 0. Right? When we find the x over here, we can see that s will be equal to 0. All right. So now we can conclude that the critical numbers are 0 and 2. Are 0 and 2. Therefore, the critical numbers are 0 and 2. Are 0 and 2. All right. So here, if you want to find the critical numbers of a particular function, first differentiate the function. All right. Differentiate the function in the first derivative. All right. Just find the first derivative of the function. And then if you find the first derivative of the function and it is linear, just set it to 0 and find the values of x, and that will be the critical numbers. All right. But to this particular solution, we are having numerator and denominator. So first, set the numerator to 0 and find the values of x, right? And then you set the denominator to 0 and find the value of x. All right. So this becomes the critical numbers of this particular function. All right. And it went ahead to ask that we should state the interval over which g of x is increasing. Over which g of x is increasing. Over which g of x is increasing. So looking at this, the interval over which g of x is increasing is basically 0 and infinity, right? And also, so we can say that, or, right, 0 and 2, right? 0 and 2. From the solutions we have obtained, when we look at the solutions obtained for the critical numbers, we will use it to conclude the interval that this function is increasing. All right. The interval that this function is increasing over, right? So the interval over which g of x is increasing, we will use the critical numbers obtained to determine the interval, all right, over which the function will increase, right? So you see 0 and 2, that is an interval. The function will keep on increasing, because when you look at this, when you put on 2, you have the function going higher, and when you put on 0, you have the function going higher, because we don't have a negative number, right? And then you can see that 0, you can begin from 0 to infinity, because the function is not a complex function, or it's not exponential, right? So now let's look at our question 12. Let's look at question 12. So the interval becomes question 11. All right. So note that. Now, question 12 says that we should find the first derivative of y equals x power sine x, right? Of y equals x power sine x. All right. So to find the derivative of this particular function, we can use the logarithmic or the logarithmic differentiation. To find the derivative or the first derivative of this particular function, we can use the logarithmic or the logarithmic differentiation. All right. So we take the natural log on both sides. We take the natural log on both sides, and then we have ln y equals ln x power sine x, right? We are all familiar with this particular function or this particular logarithmic function. All right. So now we can see that with logarithm we can bring this down, right? So we have sine x ln x. Good. So now we can go ahead and differentiate both sides. We use the chain rule on the left, and then we use the product rule on the right. All right. So now dy the x with respect to x, right? Ln y should be equal to this one. We use the chain rule, the product rule. All right, because we have two functions multiply, right? So now let me maintain this, right? So differential of dx y, we have d ln y dx, we have 1 over y times the differential of y, right? 1 over y times the differential of y, and it is equal to sine x ln x. So now let's go ahead and differentiate the right hand side as well with the product rule. So differentiating the right hand side with the product rule, when you differentiate the first function, which is the sine x, we are going to have cos x, right? Then we maintain the second function, which is the ln x, right? Plus we maintain the second function, the first function, which is the sine x. Then differentiate the ln x, which is the 1 over x, right? Now we can see that when you put this in brackets, we can have y prime is equal to y prime over y is equal to cos x ln x plus sine x over x, right? So we have y prime is equal to, when we multiply through by y, we have cos x ln x plus sine x over x multiplied by y, right? But we already know that from the question they gave us y to be x power sine x, right? We were given y to be x power sine x, right? So we say that y prime is equal to cos x ln x plus sine x over x multiplied by x power sine x. Very simple. Very, very simple. So now let me go over again. When you have this particular function, introduce the natural log on both sides. After that, you differentiate both sides with respect to x. And you know that this one we use the chain rule, and this we use the product rule. All right. So when we use the chain rule, we have this here. When we use the product rule, we have this as well. And don't forget that y is equal to x power x, right? So we put it there, and we have our final solution as this. All right. So let's move on to question number 13. Question number 13. So question number 13 says that what will be the differential function? What will be the differential function of log into x squared plus 4? The differential function of log into x squared plus 4. All right. And we know that differentiating this particular function, we can equally change it to len. All right. So to find the differential of this particular function, we use or we apply the chain rule. All right. And applying the chain rule, let's first say that let y equals this particular function. All right. Plus 4. Right. So we have y equals, changing this to len, we have len into s squared plus 4. Right. So the differential of this y prime is equal to, you know that 1 over the whole function inside the inner function, right? 1 over the inner function times the differential of the inner, right? So we have 2x. Differentiate, you have 2x, and differentiate, you have 0, right? So finally, we have the differential of this is equal to 2x over s squared plus 4. 2x over s squared plus 4. That becomes the differential of log into s squared plus 4. Log into s squared plus 4. Log into s squared plus 4. So let's look at question number 14, which says that, which is find the differential of, or the dy dx, given that y squared ys squared plus 6y plus x is equal to 0. We have to find dy dx given this particular function. All right. We have to find the dy dx given this particular function. So to find dy dx of this particular function, we use the product rule as well. So differential of this, right? We differentiate this particular function, and this will give us dy dx. Then maintain the s squared, right? Maintain the s squared. We are following product rule for this particular one, right? Good. Plus you differentiate this, right? You differentiate the second one, and that is 2x, right? Then maintain the first function, all right? Plus you differentiate the 6y, and that will give us 6 dy dx, right? Then you differentiate the x, and that will give us 1 equals 0. All right. So we are strictly following product rule and chain rule over here. All right. So now let's bring the items, the dy dx together. So we have dy dx s squared plus 6 dy dx plus 2xy plus 1 equals 0. Right? So combining this term, we can factor dy dx out, right? Factor dy dx out, and we have s squared plus 6, and then plus 2xy plus 1 equals 0, right? So we need dy dx. So we send this one to this side, right? So we have dy dx into s squared plus 6 is equal to minus 1 minus 2xy, right? So this, we need dy dx, so we find dy dx by dividing through by s squared plus 6, s squared plus 6, right? So this take off this, and we have dy dx equals minus 1 minus 2xy all over s squared plus 6, right? And we can equally write this as minus into 1 plus 2xy all over s squared plus 6. And this becomes our final solution to this particular function, right? dy dx equals minus into 1 plus 2xy all over s squared plus 6. All right. So let's look at question number 15. It's getting interesting, right? The 15th question. So the 15th question says that we should find the equation of the normal to the curve y equals sine x. Y equals sine x at the point 0, 0. At the point 0, 0. All right. So to find the equation of the normal to the curve y equals sine x at the point 0, 0, first we differentiate this particular function. All right. So when you differentiate sine x, we know that we are going to have cos x. So dy dx or y prime is equal to cos x. Right. So now we know that the first differential or the first derivative of any function denotes the slope or the gradient. All right. So we have m equals cos x. Right. So having that at s equals 0, we say that cos 0. Right. And that gives us 1. Right. So this is the slope of this particular function. All right. So the slope of the normal line, which is perpendicular to this tangent, is the negative reciprocal of the tangent slope. All right. So the slope of this, the normal, right? The slope of the normal becomes the negative reciprocal of this slope. All right. And this is the slope of the tangent. Right, so the normal becomes the negative reciprocal. So let's call this m1 and this m2. So this becomes the negative reciprocal and that becomes negative 1. All right. So now we go ahead and use the point that was given in the question, the 0, 0, to find the equation of the circle, to find the equation of the line. All right. So find the equation of the y of the line using the points. That would be y minus 0 equals minus 1 into x minus 0, right? So we have y equals minus x minus 0, right? So we have y plus x equals 0 as our final answer for this particular solution question. All right. So this is the equation of the line to this particular solution. All right. Let's move on to question number 16. Question number 16. So question number 16 says we should, given the value of f of x, the first differential of x as negative 1. So the first differential of x is negative 1, right? At the point on a continuous curve, y equals f of x, right? At the point on a curve, at the point on a continuous curve, y equals f of x, right? So what is the angle that the tangent to the curve at P makes with the positive direction of x axis, right? Let me take it again. The value of the first derivative of x is -1, all right? At the point P on a continuous curve, y equals f of x, y equals f of x, right? Now the question is, what is the angle that the tangent to the curve at P makes with the positive direction of x axis? Makes with the positive direction of the x axis, all right? So now the value of x, the value of this particular first derivative, which is equal to the -1 at the point P on the curve y equals f of x, the slope of the tangent line to the curve at the point P is given by this first derivative. You already know that the first derivative of any function represents the slope or the gradient, all right? All right. So the slope of a line is related to the angle. The slope of a line is related to the angle it makes with the positive x-axis, right? So by the formula, tan theta is equal to m. Tan theta equals to m. So we can now put the gradient, which is the first derivative, the gradient of it, over there, and we have tan theta equals -1, right? So the angle theta that satisfies this equation in the range, the angle theta that satisfies this equation in the range 0 less than or equal to x theta less than 2 theta, right? Is basically theta equals 3 pi over 4. Theta equals 3 pi over 4. So first, given the first derivative or the slope of the function as -1, we know that the slope of a line is related to the angle theta that it makes with the positive x-axis, right? That it makes with the positive x-axis, and that is what we have here. And this is the slope, so we put it there, right? So you know that tan theta ranges in this right angle, right? So looking at things, looking at the angle given, the slope that was given, the angle theta that satisfied this equation in the range 0 less than or equal to theta less than 2 theta, all right? So theta is basically 3 pi over 4, all right? So that is the angle that the tangent to the curve at P makes with the positive direction of the x-axis is 3 pi over 4, all right? So that is the explanation to question number 16. Question number 16. So now, let's look at question number 17, all right? Question number 17. It says that what will be the average rate of change of the function y equals 16 minus s squared, right? Between x equals 3 and x equals 4. What will be the average rate of change of the function y equals this function between x equals 3 and then x equals 4? All right. So that is question number 17. So the average rate of change of the function 16 minus x squared between x equals 3 and x equals 4. First, we know that this falls within an interval a and b, and they are within, or they are all inclusive, all right, is given by the average range of change, the average rate of change of a function, right, say f of x, all right, over an interval a and b, all inclusive, right, is given by f of a minus f of b, f of b minus f of a, all over b minus a, right? So here the f of x is basically the y, which is the 16 minus s squared, all right? So, and the a is 3 and the b is also 4. So now, when we calculate f of 3, we have putting 3 inside this function. We have 16 minus 3 squared, which is equal to 7. All right. And then when we calculate f of 4, we will have 16 minus 4 squared, and that is equal to 0. All right. So using the formula for the average rate of change, we can now substitute them. And then know the average rate of change of this particular function, right? So we have 0 minus 7 all over 4 minus 3, right? And this is equal to minus 7 over 1, which is equal to minus 7. All right. So the average rate of change of this particular function, 16 minus s squared, is minus 7. And this is how you go through it. All right. You have two functions that are inclusive, right? So second function minus first function all over second function minus first function. All right. So that is basically the solution to this particular question. The average rate of change of the function 16 minus s squared is minus 7. All right. So let's look at question number 18. Question number 18. So question number 18 says that we should find the equation of the normal at 1 and 2 on the curve f of x is equal to s squared plus 4x minus 3. All right. We have to find the equation of the normal at 1 and 2 on the curve this. All right. So now, to find the equation of the normal, we follow the steps that we usually go through, or we earlier on went through from these previous questions, right? So finding the equation of the normal, we follow the following steps. 1. Find the first derivative of the function to get the slope of the tangent, all right? And know that the slope of the tangent, when we calculate the slope of the tangent at f of 1, we're given the point to be 1 and 2, right? So now let's find the first derivative of this particular function, right? And that is equal to 2x plus 4, right? So at x equals 1, we have the slope. right? Which is equal to the first derivative is equal to 2 into 1 plus 4, right? So we have the slope of the tangent as 6, all right? So having the slope of the tangent as 6, the slope of the normal is now the negative reciprocal of the slope of the tangent, all right? So the slope of the normal is the negative reciprocal of the slope of the tangent. So we have this one, let's call this M1 and this M2. So we have negative reciprocal of this is going to be 1 over minus 6, right? So we have negative 1 over 6, all right? So that will be the slope of the normal. So we have the slope of the normal, so we use the 2 points to find the equation of the line, all right? To find the equation of the line. So y minus y1, which is 2, is equal to minus 1 over 6 into x minus 1, right? So simplifying this expression, we are going to have 6y minus 12 is equal to minus x plus 1, all right? So this will basically yield to x plus 6y is equal to 13, all right? X plus 6y is equal to 13. So now we already know how to go through to get the equation of the normal, the equation of the normal of a particular function. First the first derivative, find the first derivative, and then take the value for x, and then find the slope, right? So after getting the slope, you know the negative reciprocal of the tangent, the slope of the tangent will be the slope of the normal, all right? And then you substitute and find the equation of the normal, all right? So now let's look at question number 19. Question number 19. So question number 19 says, a 5 feet long man walks away from the foot of a 5 feet long man, 5 feet long man, right? Walks away from the foot of a 12 feet high lamp post. 12 feet high lamp post at the rate of 3 meters per hour. At the rate of 3 meters per hour, right? They're asking us that what will be the rate at which the shadow will increase, or what will be the rate at which the shadow increases, all right? So now, the rate at which the shadow increases, we use the similar triangles to value this, all right? We use the similar triangles to value this, all right? So from here, let L be the lamp, all right? Let L be the lamp post height. Let L be the lamp post height. So L will be equal to 12 and a half feet, which is equal to 12.5 feet. And then let M be the man's height. So we say that M is equal to 5 feet, right? So having M to be 5 feet, we say that S be the distance. We are going to represent S as the distance of the man from the lamppost, right? S. So S be the distance. The distance of the man from the lamp post, right? And then S be the length of the shadow. S be the length of the shadow, right? So from the similar triangles, we have we have x over m. S over m is equal to s plus x all over L, using the similar triangles value. All right, x over m should be equal to s plus x all over L. All right, so let's put in the values. All right, let's put in the values, and then we have s over 5 is equal to x plus x all over 12.5, all over 12.5. All right, so doing cross multiplication for this particular thing, we are going to have 12.5s 12.5x should be equal to 5 into x plus x. All right, so we have 12.5x is equal to 5s plus 5x. All right, so let's simplify this and make x the subject. So simplifying this, we have 7.5. When you subtract this from this, we have 7.5x is equal to 5x, right? So x will be equal to 5x over 7.5, right? S will be equal to 5 over 7.5, and that is equal to 2 over 3x. 2 over 3x. Now, from the question or from our parameters, we said we should let x be the distance of the man from the lamp. All right, x be the distance of the man from the lamp, right? And we differentiate both sides with respect to s, with respect to time. All right, let's differentiate both sides with respect to time. So differential of x with respect to time should be equal to 2 over 3, right? 2 over 3. 2 over 3. Now, right? So now we are given the rate, right? The ds over dt as 3 meters per hour. 3 meters per hour. So that is, we were given the man walking from at the rate of 3 meters per hour. All right, so that will be the dx over dt, right? So we have ds dt is equal to 2 over 3 times 3, right? So we have this taking of this, and we have 2 for the man, right? 2 meters per hour. 2 meters per hour. 2 meters per hour. So a 5 feet long man walks away from the foot of a 12.5 feet high lamp post, right? At the rate of 3 meter per hour, right? At the rate of 3 meter per hour, all right? And we are asked to find the rate at which the shadow increases, all right? So first, you let L be the lamp post height, all right? And then M be the man's height, all right? And then you let X be the distance of the man from the lamp post, all right, and then S be the length of the shadow, right? So using the similar triangle formula, we can say that S over M should be equal to S plus X over L, all right, and that when we fix in the values, we are having this, all right, and then we differentiate with respect to x t time. We differentiate with respect to t time on both sides. So when differentiated, we have 2 over 3 dx dt, all right, and then we have the x dt as the rate at which the man walks, right, which is 3 meters per hour. So that is given us 2 over 3 times 3, and that is equals to 3 meters per hour. So that will be the rate at which the shadow increases, all right. That will be the rate at which the shadow increases. That will be the rate at which the shadow increases. So let's look at question number 20. Question number 20. Question number 20. So question number 20 says we should find the absolute maximum value of y equals x cubed minus 3x plus 2. X cubed minus 3x plus 2 in the range 0 and 2. In the range 0 and 2 inclusive. In the range 0 and 2 inclusive. So now to find the absolute maximum value, we need to evaluate the function at the critical point. We need to find or evaluate the function at the critical point, and then endpoints of the interval. Evaluate the function at the critical point and the endpoint of the interval. So first, find the derivative of the function. The first derivative of the function, and that gives us 3s squared minus 3. All right. So set the derivative to 0 to find the critical point. So setting this first derivative to 0, this to 0, and we have 3s squared is equal to 3. All right. So we have s squared is equal to 1. All right. So the critical point is basically plus or minus 1. All right. That is the critical point. So we can see that only s equals 1 is in the interval because they said 0 and 2 inclusive. 0 and 2 inclusive. So we can't include the negative 1. All right. So we can see that s equals 1 is in the interval of 0 and 2. So it's only x equals 1 that is in the interval. All right. So evaluate the function at the critical point and the end point at s equals 0. At s equals 0. So when you have y equals 0 cubed minus 3 into 0 plus 2. All right, and that is equal to 2. All right, and at s equals 1, we have 1 cubed minus 3 into 1 plus 2. All right, and that is equal to 0 as well. All right, that is equal to 0. And then evaluating the value of the critical number at s equals 2, we have y of 2 is equal to 2 cubed minus 3 into 2 plus 2, right? And that is equal to 4. All right. So comparing various values, the absolute maximum value is basically 4. The absolute maximum value is basically 4. All right. So that is how we find the absolute maximum value of a particular function. First, find the derivative, the first derivative of the function, and that represents the critical point. All right. So we find the derivative of the function, set it to 0, find the critical points, and looking at the interval given, plus or minus 1, it's only plus 1 that will fit into the range. So we take s equals 0, fit it into this, find the value for it, and then take s equals 2, fit it into the function, find the value for it, and also we take x equals 2 and fit it into the function, find the value for it. So when we did that, we realized that x equals 4, x equals 2, when x equals 4, the maximum absolute value will be 4. All right. So now let's look at question number 21. Let's look at question number 21. Let's look at question number 21. So question number 21 says we should evaluate the integral of 2s cubed plus 2 or 5 s squared dx. All right, we have to evaluate this particular function, the integral of it. So to evaluate this particular function, we can use the substitution method. All right, we can use the substitution method. All right, so putting